Alright, then welcome back everyone. Let's solve this question 0 1. So now we are in, I guess, the second last video of this playlist. So if you are finding this playlist helpful, please like and subscribe. Fine. So I hope you read the question 1, but I'll still read it. So we are given a binary string. Binary string, that is, a string contains only characters 0 and 1. Now Alice and Bob are playing a game, so they are making alternating moves. First move is taken by Alice, and what is the move? Remove two different adjacent characters of a string and delete them. So basically, pick two different adjacent elements in the character in the string and remove them. That's the move. Alice goes first. Alice, Bob, Alice, Bob, Alice, Bob. The first Alice will remove two different characters. So this string they have given. The first Alice will remove this 1 0, right? So any adjacent characters where different Alice can pick, she can remove them. And this is a move. So first Alice takes a move, then Bob. And if player cannot take a move, they lose. Both play optimally. You have to determine if Alice can win or not. So if Alice can win, you have to print this da, which is yes in Russian, and otherwise print net, no in Russian. The question is clear, right? You are given a binary string. You are given a binary string, and what you want is you want to remove adjacent different elements. The move is defined as removing adjacent element. Alice goes first. Alice goes first, then Bob, and so on. Alice, Bob, Alice, Bob. The question is, can Alice win? Right. So this is a, I guess, simple question based on games. Usually in games, you should either think about what is the optimal move, or if you're not able to think about the optimal move, think about like what happens when the game ends and try to go back from it. So that has mostly worked for me. But let's see what can we do. So games questions, like it purely depends upon your aptitude, how well you are able to grasp it. Let's see what can we do here. So initially, let's say this is a string here, right? If you want a simulation of it, so what will happen is Alice will take a move, Alice will take a go. So Alice goes. So she can remove any adjacent elements which are different. So maybe this one, right? So it will become 1 0 0 1. Then Bob goes. So Bob can pick any adjacent elements that are different. Maybe this one 1 0. So it will become 1 0 1. Now Alice goes. She can remove first 1 0, right? So now 1 will be left. So now Bob loses. Why Bob loses? Because there are no two different adjacent elements present. Fine. So can you think about an optimal move? I don't know. I was not able to think about the optimal move. So then I thought, what happens when the game ends? So when is the game ending? The game will end if after some move the string has become empty, or all the characters have become one, or something like this. Right. So without loss of generality, let's say your game ended when all the characters were one. Right. So this you can easily extend to these two cases. It doesn't really matter. But let's say without loss of generality, our game ended after the final move. Ended when after final move the string contained all the ones. Now what would have happened one move before it? There would have been a 0 1, right, which was removed. Now it doesn't really matter where the 0 1 was, but it would have been removed, right? This 1 was there, fine, no issues, but this 0 1 would also be present. Doesn't really matter where, maybe somewhere here, it doesn't really matter, but the 0 1 would definitely be there, right? What would have happened one move before it? There would have been one more 0 1. Now again, doesn't matter where the 0 1 is, but there should be a 0 1, right? There should be a 0 1, right? That's what it is. So what are you observing here? What are you observing here? Maybe before one more, there will be one more 0 1 here. The order doesn't matter. This 0 1 can be anywhere in between. But what are you observing? What are you observing? What are you observing? A move can be made if there's at least 1 0 and at least 1 1. If you have at least 1 0 and at least 1 1, it doesn't really matter where they are present. But since you know your string is binary string, you can definitely make a move, right? So what it says is a move can be made if there's at least 1 0 and at least 1 1. Fine. Because you'll always find an adjacent pair where you have different elements, right? It's obvious because the string is binary. If there is at least 1 0 and at least 1 1, definitely you'll find an adjacent pair where you will have a 1 and 0 or 0 and 1, so on, right? You will have different adjacent elements. That's what I'm saying. Okay, so what does it say? The total number of moves that you can make. So let's just come here only. Maybe I can take an example here. Let's say 1 0 1 0 1 1, something like this. So what are the total number of moves? It will be equal to the combination of 1 and zeros, right? The combination of 1 and zeros. So you can have maybe, let's say here, how many ones are there here? 1, 2, 3, 4, 5. So ones are 5 here. And how many zeros are there here? 1, 2, 3. Zeros are 3. So you can say in the end, 5 ones and 3 zeros. So in the end, your total moves can be 3 only, right? Because you can remove 1 0 1 0 only 3 times. After removing 3 times 1 0, you won't have any zeros, right? After removing 1 0 3 times, the zeros will become 0. So this zeros will become 0 and this 1 will become 2. But 2 ones are not helpful to me, right? In the end, if I had 5 ones and 3 zeros, what I can do is I can match 3 ones with 3 zeros. I can remove it. Basically, I can perform 3 moves, right? That is, I can perform 3 moves, and after 3 moves, I will be left with only ones, right? In this case, only ones, or maybe only zeros, or empty string. So when will you left with only zeros? You will be left with only zeros when your zeros are more. Let's say ones were 5 and zeros were 7. Then after 5 moves, you'll be able to remove 0, 1, 0, 1, 0, 1, 5 number of times, and in the end, this 7 will become 2, and 1 will be 0, right? So you'll only be remaining with zeros. Now, when will the string be empty? When ones and zeros are equal. Ones are 5, and zeros are also 5. What will happen is after 5 number of moves, you will be able to exhaust all the 0 ones. You will be able to exhaust all the different adjacent elements, and your final string will become empty, right? So that's that. The total number of moves that you can perform are, if I want to summarize it, the total number of moves is simply minimum of you can say ones count and 0 count, right? Ones count and 0 count, right? So that's what you will do, right? This many number of 0 and 1 you can remove. So total moves, or you can say number of times I can remove 0, 1 or two different adjacent elements, right? So 0, 1, this order is not important, guys. 0, 1 or 1, 0 doesn't really matter, but minimum of ones count and zeros count will be total number of times I can remove 0, 1 or 1, 0, right? This is a simple thing. Fine. So this will be a total number of moves. Now you know you cannot do more than this many number of moves. So here, let's see what happens. What are the total number of moves here? So how many ones are there? Ones are here 1, 2, 3, 4. And how many zeros are there? Zeros are 3. So anyway, you will be able to do only 3 moves. You will only be able to do 3 moves. Okay, 3 moves. So you can say 1 move, second move, third move. Fine. So after performing 3 moves, what Bob lost, right? And this will hold true for any number of odd number of moves. So it is not very difficult thing to observe. If total moves are even, then Alice will lose. Else, if total moves are odd, then Bob will lose, right? So like it's, if you are like following this playlist till now, you should be able to figure this out very easily. See, if these moves were even, of course Alice Bob will happen, and now Alice won't be able to make a turn, right? Alice's turn will come, and then she will lose. If the number of moves are odd, then Alice Bob, then Alice, and now Bob will fail. So this, I guess, I'm not going to discuss it, not going deep into it, because I think we have discussed a lot of times. Fine. So if total, the main take of this video was to figure out the total number of moves. Now we have the total number of moves, and just by looking at the observation, you can figure out that if total moves are even, then Alice will lose. Otherwise, Bob will, otherwise Bob will lose, right? So in other words, you can see if number of moves are even, you can print net, that is Alice loses, or if number of moves are odd, then Alice wins. So you can just write here da. So here Alice wins, or I should write here Alice wins, right? So Bob will lose, yeah, fine, but we are only concerned about Alice winning or not. Alice will win, so that's why da. Fine. So let's just quickly code it up. It should not be very difficult. So first things first, we need to count the number of zeros. So maybe I can initialize variable z count, and I'll be lazy here, and I'm going to use stl to perform the count. So s dot end 0. Right. So since we have characters, that's why we written the character here. And now one count will be what? One count will be simply length of s minus z count. Of course, total minus the number of zeros. Length of s is simply s dot size. Okay. And now what I need to check, what is the minimum? Basically total moves. Okay. So total moves will be minimum of z count and z one count. Right. So zeros, minimum of zeros and this many number of moves I can make. If total number of moves are even, then Alice loses. So I'll have to print net here, new line, else Alice wins. So I have to print da here, new line, fine. So maybe I can capitalize them, it doesn't really matter, but fine. So let's just quickly run it and see if it works. Okay, syntax, I should write it as count, right? So here you can see number of moves you can make is 1, odd, so Alice wins. Otherwise here number of moves are 0, so even, so Alice loses. Here also number of moves are even, so Alice loses. Done net. So yeah, it seems to be working. Let me just quickly submit it. Yeah, it works. Thank you for watching. I'll see you one last time in the next video. Okay, fine.